This next section is about the turbulent flow. From the previous is a laminar flow in open channel and in closed conduct. Okay. In steady uniform turbulence, incompressible flow in conduct, the wall shear straight. We can use symbol tau naught, vary about the proportional to the square of the average velocity. This means this wall shear straight is vary with the velocity, and can write an equation like this on equation 2-1, in which the lambda is the dimensionless coefficient and rho is density of fluid. If we draw the boundary condition on the draw the control volume in open channel or closed conduct, okay, in pressure, hydrostatic pressure on the left and right now is open channel flow. Okay. P1 and P2 is equal, and flow occur as a result of the reduction of the potential energy, the difference of the set or the drop of a pressure or different pressure in case of the open channel flow closed conduct flow. From the energy equation or Bernoulli equation, we can write equation from point 1 to point 2. So point 1 is this location and point 2. Okay. And we found that the velocity the same on both sides. We can cancel, and loss is equal to the difference between 2 points, different pressure and different elevation. And from the second law of Newton, we can write equation the summation of force equal to the different pressure, and this part is from the weight of water, and this part is from the wall, the balance between the different pressure, weight, and wall shear straight. Okay. And we divided by L sine theta we divided by gamma A, so we got the equation 2-5, and substitute 2-5 in the 2-3, so we got the loss is equal to this term, and this term is cancelled. Okay, so we substitute in the equation 2-6, we got this equation 2-7. R is hydraulic radius, and R is equal to A over the P, and for pi we proved from the previous clip that R is equal to D over 4, and the loss term in both equation is the unit of meter. Give the name is HF, is a H loss per due to the friction, and defining S is a loss per unit length, so we can write equation of the head loss per unit length S is like slope, and we can solve for equation of V in this equation, and so we can write equation that V equal to equal to C square root RS, so coefficient of the C must be found by experiment, and this equation we call Chase formula. Okay, Chase formula from this, and C is a Chase coefficient is a constant for any side of the conduct or wall surface condition. And for pi is lambda is equal to F over friction factor divided by 4, and radius equal to diameter divided by 4. And the next we develop the Darcy with by equation. Okay, so this equation normally used for the pipe flow. d is the diameter of the pipe, f is a friction factor. We have to define from the pipe experiment, and this equation can be applied to open channel flow, and this is find equation for V. And for incompressible steady flow in constant depth in prismatic open channel flow, the Manning equation is widely used, so we can obtain from the chassis formula from the above equation, and we can define the equation of the Manning equation is V is equal to Cm divided by N, radius power 2/3 and slope power 1/2. So this equation is the Manning equation, Manning formula. So okay, this is Manning formula. What Cm is equal to 1, and V is average velocity, and R is hydraulic radius, and S is head loss per unit length or of the channel, or we can use call the slope of the bottom of the channel. Okay. And coefficient N is absolute roughness coefficient depending on the surface roughness. The example show in the next table. This table show the Manning N. Okay, we can expect that if the roughness is high, the Manning N is high. For example, earth. Okay, compared to the wood is Manning N is smaller because of roughness is less than earth. And if we multiply by the cross-section area, we got this equation. Okay, for Manning equation. Okay, so next we will talk about the application of this equation.